And we wake up with this question again to start the day. How many dimensions does area have? Area. 2. What are they? What are the two names we have given to the two dimensions that we associate with area? Length and width. Absolutely right. The problem with calling it length and width, of course, is it depends on how you are viewing the object, right? If I have this piece of paper and I hold it this way, everyone's happy to call this one length or width. But they all want to call this one height, right? Does it matter? No. We call it height just so we have another name for the third dimension when we move into three-dimensional figures, all right? Now, if a three-dimensional figure has a surface area, and area only has two dimensions, how can that be? How can something with only two dimensions, because remember, this technically has three dimensions, but this part that you can see only has two dimensions. How can that two dimensions be used in a three-dimensional figure? I know it's Monday morning, but I know you can do it. Why or how can something with only two dimensions apply to all of these drawings we made of three-dimensional figures? Pardon me? These are all flat, really, aren't they? Right? If I take 6 pieces of paper and put them together, I can create a box, right? But all this box is 1, 2, 3, 4, 5, and if there was a lid, 6 rectangles, yes? So those two dimensions can give us three-dimensional figures. Everybody cool? All right. Now, of course, just like you learned that there's an area of a square or a rectangle, is length times width. A triangle is base times height over 2. A circle is pi r squared. That's all you need, yes? There are other shapes. For example, the octagonal prism. You don't need to draw this. The octagonal prism, right, technically is 8 rectangles and 2 octagons, yes? And there is a formula for octagons, but never mind what it is. We're going to be dealing with these 3. Everybody cool? If you do ever find yourself with a shape, look at this. The house, right. If you do ever find yourself with a shape that you are unsure of, for example, you have a hexagon, like, oh man, how will I ever find the area of that? You do things like this. It's 6 triangles. Everybody cool? So it would be the base times height divided by 2 of each triangle times 6. Everybody good? All right. So, but, like I say, for our intents and purposes, we'll use rectangles, triangles, and circles. Everybody good? All right. So since we now have discussed the fact that all of these three-dimensional drawings are just these two-dimensional shapes put together in another way, as you all remember from probably about grade 6 when your teacher gave you a piece of paper and you cut it out, you folded it on the lines, and all of a sudden you had a cube. Everybody did that project, yeah? Nobody did? Not everybody? Where your teacher gave you the piece of paper that looked like this, with a little tab right there and a little tab right there, and you cut it up, and then you folded it on all the dotted lines, and you made a cube? Oh, yeah. They gave you a glue stick, and you put glue on the tab? Yeah, okay. Right. Every shape we deal with in grade 10 is one of them. Of course, when you did that in grade 6, the teachers just said, oh, look, you made a cube, yay! And then you probably hung your cubes with dental floss from the ceiling, things like that, and everyone was like, awesome! But they never talked about why you were doing that, is usually what happens. The reason you learned that is because it leads to this surface area. Everybody cool? All right. So We'll start with a nice, easy one. Surface area of a cereal box. I'm going to draw me a cereal box. You can draw it or not. I don't really care. There's my cereal box. And there's a bowl with a spoon. And I'm going to call this cereal Mattios. Alright, there's my cereal box. Now, you can see I have 3 measurements to the cereal box, yes? Okay, now, those 3 measurements are just that, measurements. In order to do math people gave those measurements names. One of those is length, one of those is width, and one of those is height, correct? Now, if I put the cereal box in my cupboard like this, standing up so I can read the name Mattios, that's going to make which of these distances the height? Which one? Jovan. You're going to make, this is going to be your height. Agreed? Okay. And then what would that make one of the other 2? One of them is the width. Which one? You're going to make this one the width? Okay. And then that makes this what? The length. Everyone agree? Okay. Now, if you look on your data booklet, which I should have had right there, and I don't know why it's not there today. If you look on your data booklet, perhaps it's there. No. There. No. Son of a motherless goat. There. Maybe. Hey, data booklet. If you look on your data booklet, I will zoom in. You don't need to dig out your data booklet. You can just look at this one. You will notice there is a rectangular prism, yes? Is that a cereal box? Sure it is. Yeah. How's it different from the way I drew it? And if you copied it down the way you drew it? It's lying down flat, right? Is it the same cereal box? Yes. Now you will notice that these people have labeled this the height, this the length, and this the width. Does it matter? Not at all. Right? What makes this a pain in the ass? When you call something height and you insist that it is up and down. Does everybody understand? It does not matter. When I lay the cereal box down, you're going to call this the height. If I stand the cereal box up, you're going to want to call this the height. Right? So if we go by this, and I'll keep using blue, and I go back to our one, then if we go by their method of measuring, what's on your data booklet, right, then everything changes slightly, yes? But it's not going to matter, is it? Because how do you find area? Is it add, subtract, multiply, or divide? Multiply, right? Length times width, base times height, pi times the radius times the radius. It's all times. Does order matter when multiplying? No, because multiplication is commutative, yes? 5 times 2 is the same as 2 times 5. So it doesn't matter what we call these. The key thing to remember is you can't repeat them. Once you have named a side, you got to leave it that way for that whole question. Everyone cool? All right, now, if we were not super intelligent grade 10s, we could go ahead and use the formula that has been given to us. Because if you look on your data booklet, there is a formula for this. It's really easy to work with. It's 2 WL HL HW. Or I don't remember the exact order. It doesn't matter though, does it? Because they all multiply together, right? And with these single shapes, you should just be able to fill in the formula. All right? Now, I can't fill in this formula because I don't have any numbers here, do I? So let's put our numbers in. What of those 3 numbers would you put for L? 24? Okay. And what of those three numbers would you put for W? 8, okay. And what of those three numbers would you put for H? 40, right? And you could take those and put them in here. Agreed? Easy peasy, right? You're not going to do the work in your head. You're going to use your calculator. Everything's cool. Yeah? All right. So, to W we said was 40. Sorry, W we said was 8. Length we said was 24. Then we're going to add HL. H we said was 40. L we said was 24. Plus our last one, HW, 40 times 8. And then I'm going to multiply that all by 2. Is everybody cool? We're not going to do it right now because I'm going somewhere with this. Everybody good? Single figure, easy to do, use the formula. Yeah? All right. Why?
Please excuse this interruption. Can we have the rest of the grade 12 come down for their photos, please?
Why does that work? Well, what is this cereal box actually composed of? How many rectangles? 6. So there's this side, correct? How would you find the area of that side?
Please excuse this interruption. The remainder of the grade 12, please come on down now for your photos.
She just said that 10 seconds ago, right? Like, not even. It puts me in mind. I'll just pause this. Okay, so this yellow side right here, how would you find the area of that? Karen? Length times width. If it was just a rectangle, we'd say length times width, right? But this time we've called it W and H, yeah? But it's still 40 and 8, isn't it? So there it is right there, agreed? And how would I find this area? Length times height. Now, if it was just a rectangle, we'd call it length times width, wouldn't we? Okay, and that's 40 times 24, and that's right there, yeah? And then there's this one. How would we find that guy? Length. That one is length times width the way we've labeled it, and it's right there, agreed? Okay, why then is that there? Right, there's 6 sides to it, isn't there? Right? This yellow one would have had to multiply by 2, this green one would have had to multiply by 2, and this blue one would have had to multiply by 2. Agreed? Excellent. Now that is a math class question. That's what you guys have faced in your life, yes? We've been giving you those since that very first day that we taught you length times width, yeah? Is the real world like that? Is everything in the real world a perfect shape? You got to think in the real world, yes? If this cereal box was the drawing of a bedroom, where would you put up paint? Only on the blue and yellow, yes? No paint on the ceiling. No paint on the floor. Is it still surface area? Yeah, because you're painting the exterior surface, right? But it's not a formula. Understand? The formula works for math class. In real life, you have to apply the formula sensibly. Everybody good? So, this color thing will always work. No matter how crazy I make the shape, you can do all the colors, like each face, and then add it up at the end. That will always work. But you also have these formulas available to you, if you wish. Okay? Now, I would like for everyone to please, and don't yell out the answer, because some people are faster with their calculators than others. Get me an answer to this. Some of you are going to punch this into your calculator poorly. Yes? What? Okay, wait a second. Let everybody have a chance to punch it in and make sure they are getting it right. Who has an answer for me? Oh, Hayden's going to give it because he was ready. What is it, Hayden? 2,944 centimeters. And we can't forget the squared because we have two dimensions. Yes? Why? The sheet's downstairs when you get called. The little card will be downstairs when grade 10s are called. Everybody okay? Everybody was able to get that with their calculator? Javon? I was get out of my head, Javon, because I was about to say that's a three-dimensional object, yes? Why is it only two dimensions? That's what Javon just asked. Why is it only two dimensions? There's three dimensions in the drawing. Why is the answer squared? Oh, ladies and gentlemen. I'm hurt. What? It's area. Area is what? Two dimensions. How did we find the blue area? Length times width to give us two dimensions, yes? How do we find the yellow area? Two dimensions. How do we find the green area? Two dimensions. It's all two dimensions because surface area only cares about what? It's in the name. It only cares about the surfaces, the outside. Okay? That's why it's two dimensions, even though we're dealing with a three-dimensional figure. Because all a three-dimensional figure is, when you're doing surface area, is a bunch of two-dimensional figures put together. Everybody cool? All right. Now, please turn the page over, and we are going to make some changes here. This was the pre-diploma 10 question. I don't know why it ended up in your people's book. So you're going to make some changes. It is not a rectangular pyramid. It is a square pyramid. And it is 32 feet and a height of 65. No, feet. Didn't I show you guys that thing from the TV or from the movie? I showed it to another class. Never mind. Did I show it to you? I lose track. So, a square-based pyramid. Now, we all know the pyramid starts with a regular shape and then that shape repeats, yes? So that square base, we like to draw it on the bottom because we like the base to be the bottom, don't we? Is it the bottom? No, that's only the way we name it. If you go to the Louvre in Paris, there is a sculpture of a square pyramid that sits on its point. So where's the base? No. The base is the point is the bottom. Is it the base? Where's the base? Up here. Because the base is the shape we start with. Okay? Get base as bottom out of your head. Everybody cool? All right. So if it's a square base, and we're going to draw it on the bottom because we get to draw this. We're in charge of this question, yes? If it's a square base, what do I know about the two sides? What do I know about these two sides? They're equal. And how big are they according to the question? 32. Everyone agree? Okay. And then a pyramid is made of 4 triangles, yes? So there's 1 triangle, 2 triangles, and in the back here, there would be 2 more triangles. Everybody cool still? Okay. Now, if I was going to draw this out flat, it would look like that, yes? And those 4 triangles would fold up, and we'd have a pyramid, just like we were doing grade 4 origami. Everybody's good? All right. Now, if I want the surface area of this, is there a formula for it? Is it a single figure? Is this one figure that I've drawn on the page? Yeah. and single figures get a formula, right? So on our charts or on our data booklets, we have that formula. It is right here, yes? Now notice, I've already highlighted it. This looks pretty much like what we drew, right? Okay. Except there's a base, there's a height. There's also this line called S. We're going to talk about that in a minute because you can see it's over here in the formula, can't you? So, the formula is 2bs plus b squared. Let's go back to where we were working. And, I can't stress this enough, write the formula. If you write these out, you cannot do them wrong.
Please excuse this interruption. Could we have all grade 11s come down to have a photo taken?
No, now they want all the grade 11s. Or, more likely, she's going to come on in a minute and say, whoa, 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 half the grade 11s. Everybody cool? 2bs plus b squared, yeah? That's the formula for it, right? Okay. Now, if you look on the drawing, it tells us that b is this along the bottom, yeah? And s goes up the side, right? And h goes right up the middle. Is everybody cool? So let's go back to our drawing. Do we have the b? What is it? 32. So I can go 2 times 32 s plus 32 squared. Everybody agree? Everyone's happy with that? I'm about to get to that. Why don't we have an s? Read the question. Tell me why I had to leave s blank. Talk to your neighbor if you need to. Okay, why is S still S? Okay, go. There's no number for it. Why is there no number for it? What was I given? I was given a height of 65, yes? And height of anything goes right up the middle, doesn't it? Because this pyramid we can see is a square plus 4 triangles, yes? Right? And if we were doing grade 3 math, it would be length times width plus 4 base times height divided by 2, right? And that 4 and 2 would do what? What would happen with that 4 in the numerator and that 2 in the denominator? What? Ladies and gentlemen, really? 4 in the numerator, 2 in the denominator. What is that? 2. So what will happen here? That's a 4 in the numerator, just like that, and a 2 in the denominator, just like that. So what will happen to this 4 and the 2? The 4 will become a 2, and I will have BH. Agreed? Now, in a square, LW are the same, aren't they? So it would be B squared plus 2B, but not H, because once H is this H is this line on this triangle, isn't it? Once I fold that triangle up, that line stays on the triangle, yeah? So it would be right here, correct? Is the H of that triangle the H of the pyramid? It is? When I stand up, you measure my height up the side of my body? Where do you measure my height? From the middle straight up, yeah? So, once I fold this triangle up, you agree that this red line is here, yes? But that is the height of the triangle, is it not? It is not the height of the pyramid. How tall is the pyramid? 65, which I'm going to draw in blue, which would go right down there, wouldn't it? Now, how do I find S? Talk to your neighbor. Because I don't have S, but I need S. And there's a problem here. S on the pyramid is the H of the unfolded pyramid, isn't it? But the H on the unfolded pyramid is not the H of the pyramid, which is why just learning formulas is totally useless to you, right? That's why we have to look at what makes these shapes. Everybody good? Go. How am I going to find that red line right there? I'll wait 15 seconds. See if anybody has an idea. Five bomb-bird flaps of his wings. 15, I mean. Who has an answer? What can I do? Don't say anything out loud. How many people think they have a method to do this, to find me that red line? One hand. Two hands. Okay. I trust you both are correct, so I'm going to give a hint to everybody else. I'm going to draw another orange line. I'm going to draw that orange line right there. Does that help? I will draw what I have drawn over here. Blue, orange, red. Now I'll wait 15 seconds if you can tell me a way to find the red line. You got one? Don't say it out loud because that's only 3 people in the whole class. 4 people. 5 people. All right, that's out of time. If you still don't have an idea, now I'm going to add this. This blue line goes straight up from the bottom of the pyramid, yes? Which must mean it makes a 90-degree angle. Now, do the other 26 people in the class have an idea of a way to find the length of the red side? I'll wait 15 seconds, see if 26 more hands go up. We're up to 5. And time is up. Well, 5 of you are good. I'll add a third hint. Oh, 7, 8, 9. Fourth hint I'm not writing down. You learned it in grade 7. And I'm out of time to spend on this. What kind of triangle is that? Right angle triangle, which means you know something about the 3 sides, don't you? What do you know about the 3 sides? A squared plus B squared equals C squared, which I will never ever say again in this class because it's a silly way to teach it. It is Pythagoras. If you say A squared, B squared, C squared, if I change those letters, honestly, my grade 10 students say to me, I cannot do that question anymore, Mr. Myers. Why? Because you didn't use A squared, B squared, and C squared. If I change those to R, S, T, a great many of my students will not be able to do this question. Or if I do this, this is my favorite. If I do this, C, B, A, they do it wrong. They tell me that A is shorter than the other 2. I know that, and you know that. But a great many of my students do not, because they were taught A squared, B squared, C squared. And if you change the letters, you can't do it. Same way all of you say the base was the bottom, right? Till you go to Paris and turn the pyramid over. What's the base? The point.
But what if they built it from the point up? Then there would be the base.
No.
Wouldn't it?
No. So, do we know this blue line. Blue line in the pyramid, blue line in the drawing. How long is it? 65. Excellent. Do we know the orange line? What is it? 16. How many people wanted to say it was 32? I hope no one. Why is it 16, Hayden? Because it's half of 32. Now, can I find the red line? It is the square root of what? 65 squared plus 16 squared, yes? But it is also the S from right there, isn't it? So now, could we use the formula to solve this? Great. It would be 2 times 32 times the square root of 65 squared plus 16 squared plus 32 squared. And you would punch all that into your calculator. Now, it's going to give you a weird decimal, and that's cool. Don't worry about that. All right? Everybody try to punch that in. A great many of you will try to punch that in one step and get the wrong answer. There's a lesson to be learned here, so I'm letting you try it now. Go. Yep. Who has an answer for me? And bear in mind, you may very well not have the right answer because, again, if you have written this out, are you right? Is that all the numbers you need to solve this? It is, isn't it? So if you get to there, am I very, very happy? What gets me turning cartwheels? If you can figure out how to do this on your calculator. A great many of you, like I said, are probably going to get the wrong answer when you go to your calculator. Because punching stuff into a calculator is very different than doing the math, isn't it? So, who has an answer for me? Again, it doesn't matter if you're wrong, because if you understand this, you're where you need to be. The calculator stuff is just from practice. So, who has an answer for me? I will take it rounded to 2 decimal places. Nobody wants to risk it? What risk is there? You're going to say some numbers. The worst thing that can happen is I say, you didn't punch that into your calculator right. How many of you are confident you can use a calculator? Great. So somebody give me an answer. Karen. 287,000. I'm going to write a couple of these down. 287,000. Who else has an answer? I know there was other numbers. I'm just brainstorming here. What do you have, Anusha?
5,308.
5,308. What do you got, Jacob?
23,248.
23,248. Nobody else wants to risk it? As you can see, those are vastly different answers, aren't they? One of them is right. How do you know which one is right? Well, you could guess one of 3, or you could do what you should do every single time. You should estimate. Okay? What is this about? Well, 60 squared is 3,600, yes? 16 squared is 256, yes? So that's about the square root of 4,000. Everybody with me? And the square root of 4,000 is what? Pardon me? What's the square root of 4,000? It's 40 times 100. Square root of 40 is about 6. Square root of 100 is 10. So this is going to be around 60, isn't it? That's cool. I'm going somewhere with this. If you guess that to be about 60, right? What's 2 times 32? That's also about 60, isn't it? Everybody agree? So I would have 60 times 60, wouldn't I? Which would be 3,600, yes? This is 30 squared, yeah? Which is 900, yes? So 3,600 plus 900 is 4,500. That's a pretty good guess, yes? Before I even touch my calculator. So now, which one of those is right? It has to be that one, doesn't it? So you take 2 seconds and do an estimate. Then you punch something into your calculator and you hit equals. And some of you got that, some of you got that. But if you knew that your estimate, that it had to be around 4,500, and you got one of these two, would you hand that in to me? No, because it can't be right. Does everybody understand? I know as well as you do that you have seen your previous math textbooks, and it always says, calculate the following, provide an estimate first. Didn't it? And how many of you ever bothered to do the estimate? None of you. You went straight to your calculator and started working, yes? What happened today when you went straight to your calculator and started working? I got those 3 answers. And I bet if I forced you all to give me an answer, I'll get a whole bunch of different ones, wouldn't I? Why? Because calculators are not math. They do what you tell them to do. These are the right answers for whatever Karen and I can't remember who gave me this one, for whatever they punched in. But that isn't the actual math that happened. Everybody understand? Okay, now to punch that in your calculator in one shot gave us crazy answers, didn't it? How can you make your life easier? Punch it in pieces, right? So Hayden told me this was 66.9, which is a rounded number, isn't it? So then I bet if I were Hayden, he went 2 times 32 times 66.9 to get a number here. And then, in a second number, he did 32 squared, which is whatever it is. I think it's 3,000 or 1,024. Is it? Plus 1,024. Then he had 2 numbers here, whatever that was, which was 64 times 66.9. Did that on his calculator, got a number, and then he added 1024. If you go step by step, you're also going to get the right answer. Okay? We will practice how to get everything punched in one go. But let's get the right answers first. Everybody cool? All right. Next question. Draw and calculate the surface area of a cone with a radius of 15 and a height of 22. So let's draw our cone. Well, how does a cone start? Micah. Circle. Does it have to be at the bottom?
No.
When I buy ice cream, that cone, the circle's not at the bottom. If the circle's at the bottom, it's tough to lick that ice cream, isn't it? Right? So, I'll ask again. Does the circle have to be the bottom?
No.
But is the circle the base?
Yes.
Yes. Is everybody cool with that? All right. I'm going to draw an ice cream cone. There's the circle. Why did I draw it squishy and oval-like? Because you can't draw it, right? If you were looking at a cone, it just looks like a triangle, doesn't it? Unless you tip it a little. And if you tip it a little, it doesn't look like a perfect circle unless you look straight at it. And then when you look straight at it, do you see the rest of the cone? Do you? No, you just see the circle, don't you? All right. There we go. That circle has a radius. Where is the radius? Half of the circle. So there is my radius. It's underlined in red. I drew the line in red. What number will that be? R equals 15. Everyone agree? Okay. Now, it also has a height of 22. Where is the height? Karen. Right down the middle. Yes? And that h equals 22. Everybody agree? Now, is that a single figure? Is a cone a single figure? Yeah, it's got a name. It's just cone. Everybody with me? So if it's a single figure, does it have a formula? Of course it does. We go to our formulas and we look. And we see a cone, surface area, pi r squared plus pi r slant. Right? So, I have an r, right? It's surface area equals, I'm going to write out the formula, pi r squared plus pi r slant. Why is it that? Well, pi r squared gives me the circle, and we already talked about how the rest of a cone is just part of a circle wrapped around it, isn't it? So we still need pi and we still need r because we're dealing with circles. But we're missing the s. Now you guys are smart people. In the previous question, what did we have to do to find s? What did we have to do to find s? Pythagoras. If you do it once in math, what does that mean? You do it every time. So, do I need a slant here? Do I need an s? I do. What finds me s? Pythagoras. For slant. When? Always. And Pythagoras always works. Our triangle looks like this. H, 22. R, 15. What is S? The square root of what? (22) squared plus 15 squared, which is the square root of 484 plus 225, 684, 709. Yeah? Now, that is going to give me a yucky decimal, isn't it? Barf. Yeah? And we're going to have to round that off, aren't we? Everybody agree? Okay. I want you to do me a favor, because as you go further in math, you're going to use decimals less and less. This is not perfect, is it? The square root of 709 is 26.62, right? Okay, so I'm going to write that here, 26.62. But notice I'm leaving the 709 black, yes? All right, so now we know our S equals the square root of 709. Now, do we have everything we need to fill in that formula? Do I have an R? Yep. Do I have an S? Yep. And we already know what pi is, don't we? What's pi? No. 3.14 is what you've been told to use for pi. What is pi really? An infinite amount of decimal places, yes? Goes on forever. If you wanted to give me an exact answer, could you? Not if you use the decimals, could you? Because this 26.62 also goes on forever, doesn't it? If you tried to write this answer for me using decimals, and I told you I wanted it exact, could you do it? No, you would die, because you would spend the rest of your life writing just the decimals of pi. Everybody understand? So, this is where the first major change in how you write your math down is going to be. If you are going to grade 11 and 12 math, you are going to be doing what I'm about to do. You will leave things like this and pi like that. Is everybody with me? So you would write pi, what's R? 15 squared plus pi, what's R? 15, and what's S? The square root of 709. As you go further in math, this is what your answers would look like. 225, because that's 15 squared, pi plus 15 root 709 pi. And that is one of the best answers you could give me. Okay? Is everybody with me? This is what we call an exact answer.
Please excuse us.
That'll be grade 10s.
We have grade 10 students in Mr. Eason, Mr. Kleisinger, and Miss Crosa's class. Please come down to the rotunda for your photos.
By homeroom or by whose class they're in now? What do you think? I don't know. Do you? Of course it's a good question. I assume it's by homeroom because they gave out the cards. So if you're in one of those three people's homeroom, go down and get your picture taken. Kleisinger, Kraus, and who? Easton. If you're in Kleisinger, Kraus, or Easton, go get your picture taken. Now, is this a useful answer in real life? Can I go to Home Depot and say, hey man, I need enough paint to paint 225 pi plus 15 times the square root of 709 times pi? No. This is a math class answer. In reality, what are we going to use? The decimals, right? So in reality, we're going to punch this in and we're going to hit, depending on your calculator, you can punch this in. And I'm going to write down the actual buttons you would hit, and then everybody can try it. You're going to hit 15. Then all of you should have an X2 button. X with a little 2. Then you're going to hit times. Then you're going to hit your pi button. Every one of your calculators has it. It might be a shift to get to it. Plus 15 times the pi button times, and then depending on your calculator, however you do square root. Some of your calculators, you hit square root 709, and some of you hit 709 square root button. Then equals. If you make a mistake, the mistake most of you are going to make is not hitting equals. Now, before you punch that in, should you have an idea of what the answer is going to be? Yes. Isn't pi pretty close to 3? And 225 times 3 is pretty close to 700, isn't it? Everyone agree? The square root of 709 is pretty darn close to the square root of what? That's 70 times 10, right? Square root of 10 is about 3. Square root of 70 is about 8. 8 times 3 is 24, yeah? So could you use the square root of 24 there? It's not, or a square root of 24. We know what it is. I've got it on my calculator. It's 26.62. So is 24 a pretty good guess? 24 times 15 is 240. Plus another 120 is about 400, yeah? 700 plus 400. So our guess is about 1100, right? Now punch it into your calculator and see if you can do it right. Of course you can. What do you get? Everybody try, give me answers, because it might be all over the map again, yes? Martin. 1,961 point blah, right? Did everybody get that? If you got something else, tell me what you got. If you didn't try it, that's cool too. Is that a fair guess? It is, right? We guessed around 1100. And we did a lot of rounding in there, didn't we? Right? Oh, I forgot to do 400 times 3, because pi is 3, right? So 400 times 3 is 1,200, and our guess was 1,900. We got 1961. Do we know we did it right?
Please excuse this interruption. Can we have students who are currently with Ms. Krause, Miss MJ?
No, they meant currently.
Come down for your vote.
Is everybody cool? Everybody understands the difference between an exact answer and this? Do I care which it is? In your work, if I leave it blank, do I care? If I give you a multiple choice answer and they're all in a bunch of decimals, then you got to use the calculator. Is everybody good? But Adrian, you're not in one of the classes.
I'm in Mrs. Ross.
Yeah, but she just came on the PA and said only if you're in her class now. That is what she said, right? And all 31 of us believe she means they want the grade 10s that are in Miss Krause's classroom right now, not her homeroom. That's what that meant, yeah? Okay, because that's what I'm going with. Is everybody cool with the math here? All right. So I left you. I'm going to stop talking now because I'm frustrated. Not at any of you people. You're going to do number 4, and you're going to start working on page 30, 31, and 32. Now, please notice weird stuff is going on 31 and 32, right? Right? Is that a single figure? No, it's a rectangular prism down here and a rectangular prism up there, right? So there is no formula for that. But what would work? Finding all the sides. And then doing what? Adding it up. I don't expect this page to be done incredibly well the first time through. So do yourselves a favor and leave, if you can, some room to do the work tomorrow when we go over it, right? You try it over here and leave this over here. You get an answer, say you get it equals 474, and I show you the right answer tomorrow, and it's not that, then you're going to want to go over here and do what I did. Everybody with me? Everybody cool? Okay, go. Page 31 or 30. Now, did I take your people's quiz marks in yet? I took them in? They're on check my mark? Yeah. Aces. Yeah, go do whatever you need to do.
I wasn't here when you talked this. So
yeah. It's going to be on the YouTube, but I'll show you real quick. So, how far did you get? You got to this. Okay. So this